Yeah.
What if everyone just Googled it?
Oh. She cheated. She cheated.
Using your resources.
I think you just cheated.
You're just mad because you didn't think of it first.
What was it? Well, I did think of it. Am I allowed to say it?
If you're allowed to say it, that means everyone gets 1 bonus point.
Just do it. That's fine. I don't care.
What do you got?
Okay, so you draw a star, and you put a dot like on each. So like, how do you draw it? It's hard to explain.
Okay.
Okay, so on the very tip of like the star, like at the top, do 1 dot, and then across the top line do 4, like at each little gap, and then in the middle, like of the corners, do 2. Do 1 in the very center, yeah, and then 2 at the bottom.
Boom. Satisfied? Are there 10 trees there? Of each circle represented a tree? Are there 5 different rows?
So everyone in the class gets a bonus point? Thanks, Lynn. Thank you.
Look at that. You guys owe her a milkshake or something. Pretty huge.
I could have just went and Googled it over the weekend.
God bless you.
Everyone would have forgot.
So here's what I find kind of funny. Somebody utilized the resource, and you guys go right on the offense, going, or the defense, like, dude, you cheated. Why?
Just
Did I?
Not want your bonus point?
Did-
I'll take yours.
The kid from Parker is still playing baseball on his phone.
you don't. She said no.
I liked it because you know what? It allowed you to utilize the resource. You gained the knowledge of how to do it. I love it. I love it. Okay, questions on the homework. Questions on the homework. What we got?
She does talk about it.
Alex, pull out my phone. That's like literally word for word.
What happened?
I'm just making fun of Alex.
No, nothing wrong with that.
Bully.
She's a bully?
It's not.
I have no problem you hit a girl. Just don't come whining to me when her dad comes in and thumps you.
Okay, right.
I have no problem.
It was getting loud.
And whining to me if you come back
Dude,
down.
that was not bad. Dude,
Yeah, go ahead.
Yoshi,
You never have to ask. You can always go. You know what?
the second day got
17 through 29. Let's hit them.
Did she go? You would.
All right.
She probably just terrible.
17 through 29. You need one light on?
Yeah.
Okay, I'll get it on. I'll turn the back ones on. I'll turn the side rails on. So much more light in here. All right, 17 through 29 says, find the domain of f and g, and then find the domain when you added them together, subtract them, multiply the f together, divide by, and then find. Okay, cool. So first thing, take a look at 17. The f at x, what is the domain? What's the domain of the top? Okay. What about on the bottom? Same. Okay, so here's the nice thing. Neither of the domains of the original are restricted. So it's possible that if we add them, subtract them, multiply them, we won't have restrictions as well. So the first thing asked us to find f plus g. Okay, so if I find f plus g, I'm going to get negative 3x plus 6. I just added them together, combined like terms. Do you agree? What's the domain? Same thing. There's not a restriction here. Okay. Then the next one asks us to subtract them. So I'm going to subtract. I'm going to go f minus g. So I'll be subtracting this. So 2x minus 5x, that's 7x. And then 3 minus 3 is 0. Okay, cool. It worked. If I subtract them, I get that. What's the domain? Same thing. right. Then they wanted us to multiply them. So that's going to be this times this. 4-letter F word math called FOIL. So I'm going to get 6x outside minus 10x squared. Inside is going to be plus 9. Outside is going to, or last is going to give me negative 15x. I guess I could combine like terms if I wanted to, but I'll just leave it as is. What's the domain of that? What's the domain of that? Same thing. We're not running into any restrictions yet on this problem. Let's split you up. Okay. So that was FG. What about F times F? That means I'm going to take 2x plus 3 times 2x plus 3. Because our equation F was 2x plus 3. FOIL that, so I'm going to get 4x squared. Outside is going to give me plus 6x. Inside plus 6x. Last plus 9. I guess I could combine like terms together, but what would the domain of that be? Same thing. F divided by G, which is this. What's that domain? Is it the same thing, or is there a number that will make it an undefined term? Yeah, x can't be 3/5. Okay? So the domain of this could be negative infinity to 3/5, rounded bracket 3/5 to infinity. Which basically means rounded bracket at the 3/5 means we're not including it. We're including every number to the left of it and every number to the right of it, no matter how close we get to it. Okay, so the domain is restricted on that one, even though the original domains were not restricted. And then the last one, I believe, says G divided by F. So G divided by F is 3 minus 5x over 2x plus 3. What's the domain of that one? What is it?
Wait, negative 3/2.
There you go, negative 3/2. So negative infinity to negative 3/2. Negative 3/2 to infinity. Okay? Does everyone see where we got that number from? We just took the denominator and solved it, set it equal to 0 and solved it. So on F over G, I took 3 minus 5x, set it equal to 0. You add 5x to the other side, you get 3 equals 5x, divide by 5, so x equals 3/5, and that's where that came from. On the bottom one, 3 minus 5x over 2x plus 3. You set 2x plus 3 equal to 0, you get 2x equals negative 3, so x equals negative 3/2. And if you plug that in, you'd get a denominator that would be 0, which is an undefined term. What else do we have from the homework? Yeah. Number 8. Okay. Problem number 8. We have F over G at negative root 3. So we have f at x, which is x squared minus 3 over 2x plus 1. So what this is saying is we have our problem set up. All I need to do is I need to take this and plug it in for my x values here and here. So if I get negative root 3 quantity squared minus 3, and then 2 times negative root 3 plus 1. This right here is going to give me 3, so I get 3 minus 3. So I get 0 on top, which is good. Let's just make sure I don't have 0 on the bottom. That's going to give me negative 2 root 3 plus 1. I think I can leave it like that. So 0 on top gives me what for an answer? 0. So the answer to this one is just 0. Okay. Is 0 over 0 0, or is it undefined? Undefined. Okay. What else from the homework should we go over? We good? Sure? Okay, make sure your name is on your assignment. If you have a top mark, go ahead and turn it in today. Pass it on up and then down. If you are turning an old assignment in, just write me a note at the top that's an old assignment so I know that. And pass that also in. If you got a middle mark or a bottom mark, you're not turning it in today. Turn it in next time completed. For a middle mark being a 9 and a bottom mark being an 8. Anybody else got no one? Any more? Okay, if you have a blue notebook, you can get it out. We'll go over that a little bit. Notes on that. All right, ready? Okay. So let's do a little discovering. I think we can do this. I think we can manage through this stuff. If I had my XY axis and I had drawn some line, and I guess it's this. We could probably justify this line being a linear equation of y is equal to okay, make that work. So -1, -2, -3. So if I went up 2, right 1, it should work out. Okay. So I would like to reflect this graph over the x-axis, or reflect it over the x-axis. First thing on the book, reflect over the x-axis. Okay, guys? So, if I wanted to reflect this over the x-axis, that means the x-axis right now would be acting as a mirror. The x-axis was acting as a mirror. That means that whatever below it becomes above it, whatever above it goes below it. So, if I wanted to reflect this over the x-axis, this point here is going to go here. Is that okay? If I wanted to reflect it, that means this point here, which is and then if I were to draw this line in, I've just reflected it over the x-axis. Do you agree? So the x-axis is acting as a mirror. Whatever's above it goes below it. Whatever's below it goes above it. Oh, I didn't rotate, no. Okay. What point is this? Give me what the actual coordinates of that point would be. 0, -3. what was the coordinates of this point right here? 0, 3. Okay. What is the coordinates of this point right here? 1, negative 1. What is the coordinates of this point? So what changed of our points? What do you mean? How did the y change? So we changed signs. Change signs. Okay. Okay, I agree. Do these have to be perpendicular if they reflect over? Let's see if that'll happen. If it was truly if it was true to form what we said, that means that of a slope of 2, if they weren't perpendicular, that slope would now have to be negative 1/2 if this is true. But you just told me that my y value changed signs. My y value changed signs. So my equation is now this. Did I follow the instructions right? Did I do that right? Okay, I understand, but right now I have a negative y because you told me the y value changed to a negative. Still following? So if I change the y up there, and we know we don't like to have a negative y, so what would I have to do to that newly modified equation in order to make it algebraic for us? Distribute the negative, so I'm going to change all the signs. Good. So basically all I'm doing is I'm multiplying everything here by negative 1. So I'm going to get y equals negative 2x plus 3. So if this value is plus 3, that works. My slope is down 2, 1, 2, right 1. It works. Are these lines perpendicular? No. Good. So I have a slope of one line being 2. I have the slope of the other line being negative 2. They are opposites of each other. One's positive, one's negative, but they aren't opposite reciprocals of each other. Okay, so if I wanted to reflect over the x-axis, I can change my y value and then change all the signs, because that means the y value changed. Huh. What do you think? Is this a rule? Can we say this? Reflect over x-axis, our y value switches signs. Well, let's ask this. Could one example be enough to make a rule? Did we get lucky on the one and actually find the rule with the one? Maybe. But usually one instance won't be the entire problem. So I think right now, maybe we could call our rule, if we wanted to reflect something over the x-axis, which is the horizontal of our xy axis, our y value switches signs. Our y value switches signs. Basically, we can take whatever our equation is and multiply everything by the negative, and we're going to get the appropriate equation as far as linear goes for this. So this looks like a rule that's going to work for right now. But let's test another situation to see if this truly does work. Can I move on? Okay, so let's go a little bit deeper. Let's take I don't want to go with that big line. All right, let's go with Mr. Parabola. Let's go with y is equal to x minus 3 quantity squared plus 2. So this, I know this will have a vertex at 3, 2. So 1, 2, 3, 1, 2. Does this parabola right now open upward or downward? It opens upward. How fast does it grow from that point, which is the vertex? Do what? Just, it's normal. So from this point, I don't know if you guys have ever seen this before. So being my value out here is a 1, that means from this vertex, I'm going to go right 1, up 1, left 1, up 1. And then I'm going to go from here, I'm going to go right 2, up 4. Oh, you're right. So from here you go right 1, up 3. But if you save here, so right 2, up 4. So your pattern graphing's right. You're 1, 3, 5. You're absolutely right. So right 1, up 1, left 1, up 1, right 1, up 3 from the next point, or you can go right 2, up 4. It's going to be the same idea. Same exact pattern. So this is what our parabola should look like right now. And let's get all the points in place. So this is 1, 2, 3, 4, and then 5. And then 1, 2, 3, 4, 5, and 6. Okay? So let's label our vertex, which was 3, 2. What would this point be right here? Right 1 from 3 is what? 4, 3, good. So what would this point be right here? 2, 3, love it. What is this point then up here? If I went from my vertex, I went right 2, what do I get to? 5, and then I go up 4, so 5, 6. And then this point right here would be what? 1, 6. Does everyone feel okay about how we just established those points? So if I reflect over the x-axis, that means that everything above the x-axis is going to go below it, and anything below it would go above it. Well, in this case, everything happens to be above the x-axis. Do you agree? Okay? So if what we are saying, if we wanted to reflect this over the x-axis, the point 3, -2 should be the new vertex. The point 4, -3, the point 2, -3, the point 5, -6, and the point 1, -6. All of these should work. What is that point? That's the 2, -3, right? And then this point is 1, -6. So what do you think? Can you make this work in your head that this particular parabola has reflected over the x-axis? Yes or no? So all we did theoretically is we just changed all of the y components of our known points from graphing to an opposite value of what they were. Is that okay? What if the value had been like something common 0? How do you change the sign of 0? You don't. It's still going to be 0. So if something did fall on the x-axis and you said reflect over the x-axis, the reflection on the x-axis is the x-axis. So let's see if this problem can work. So I'm going to split the screen. Okay? So originally we had this equation here. Right? And all we did was change the y values to a negative value. So all we did was make this, supposedly. Do you agree? Does that seem okay? And we don't like having negative y, so what should we do to the whole equation? Multiply the entire equation by what? -1, which means this equation is now going to become this. Negative on the outside of a quantity is going to be negative. That's not going to change anything inside because it's grouped. And then do you agree? Now here's the tough thing. Should I have distributed? Should I have made that a positive? I don't know. Should this have been made a positive when I multiplied everything by negative? Yeah, it's grouped together. So it's grouped together, so that meaning that's grouped, meaning if you FOIL this out, then you distribute the negative over, that would be completely appropriate. Okay, so let's ask ourselves a few things. What is the vertex of this new equation if we're going to test our theory? What is the vertex? 3, negative 2. So this is going to be a new vertex. What is the vertex of our reflected one? What's our vertex of our reflected one? 3, negative 2. We might be onto something. Does this parabola open up or down? Down. Does this grow at a normal rate going down? So from here, if I went right 1, down 1, left 1, down 1, and how you guys are saying if I went right 1 and down 3 more and left 1, down 3 more, right? What do you think? Is our rule going to work? So our rule originally was reflect over x-axis or y value switches signs. That was our rule. Reflect over the x-axis, our y value switches signs. Did we get lucky because we chose one linear equation that worked and followed this rule, and now we have a parabola? Did that work? Did I choose from an infinite amount of problems, of linear problems, and an infinite amount of parabolas, and find a rule that just worked for those 2 cases only? Did I get that lucky? Should I go play Powerball tonight because I got that lucky? I mean, would you agree that that would be, that I found an equation that rule works for both, one as being linear, one as being quadratic? Am I that lucky? Is it because I have a degree in math that I know these are the only 2 cases that work? No. I think we might be able to say this rule is pretty simple. You reflect over the x-axis, the y values change the sign. Does that make sense to me to say that? I don't think that's that hard. But I might be wrong because I know I'm a teacher. So if we have an equation and it says, hey, I want to know what the equation that would flip over the y-axis would be, that would mean that if I change the y to a negative, and then I multiply the whole equation by -1, that equation would be the one that would then flip over the x-axis. Okay? Can I go one more? Can I go one more? What happened? Yeah, I spoke her in action. That was really happy. All right. So let's use a little of our knowledge. If we reflected over the x-axis, the y value changed. If I reflect over the y-axis, what might you maybe able to conclude? The x value changes. Let's see if this is right. Okay? So let's create ourselves a linear equation. I don't know, y equals -3x plus 2. So 1, 2. From there, I'm going to go down 3 and write 1. So this is the point 0, 2. This is the point 1, -1. Do you agree? if I reflected this whole thing over the y-axis, so if I reflected over this line, is this point here going to change? No, probably not. What about this point? If I reflect it over, does this point come here? If I reflect over the y-axis, does that point come over there? So I think this might work for us. So what is this point now? -1, -1. So we changed what value? So we changed signs on the x. So if I changed signs on the x, what would this sign change to then? What would this change to? Y equals what? 3x minus 2, or does it stay plus 2? Plus 2? Let's see if this equation works. Stay with me, we're almost done. Shh. So, this should be my y-intercept because that's plus 2, yes? My slope is up 3, right 1. Or down 3, left 1. Negative over negative is positive. Wow. So if I reflect over the x-axis, I change the component of the y, and then if I had the equation, I made y negative, then multiplied everything by -1 and changed all the signs of the equation. If I reflect over the y-axis, I change the sign of my x value, and that's the only value that switched signs. Do you think this worked with a parabola? I think it might be a pretty good hypothesis. So reflect over the x-axis, the y value changes, and then if you have the equation, multiply everything by negative, and all the signs are going to change. If you reflect over the y-axis, change the sign of the x value only. What do you think? Seem okay? Seem like good math or bad math?
It's always bad math. I hate it.
You're right. All right. You gonna let me go one last spot? Come on, have fun. All right. All right. I want to know how I shift up or down. I want to know how I can shift the graph up or down. Meaning I take the whole graph and just move it up, or I take the whole graph and just move it down. Okay? So what I mean is this. Let's say I had a parabola like this, and I wanted to shift it up 1. I would like to do this. Or if I wanted to shift it down 3. Ooh. That come out of you? Oh, son. Look at that. So okay, so general form, actually this, y equals a quantity x minus h quantity squared plus k. What value is going to change to shift it up or down? The k value. So a positive k moves up, a negative k moves down. Yo.
What is the h?
H is the x component. Okay? So on a parabola, if I wanted to shift left or right, this might be a little different. It is. Why is it the opposite? It's in the parentheses. It's grouped together. Okay? Being it's in parentheses, if I want to shift it right or left, if I shift it right, I want my h value to be x minus h, and it's going to shift right h amount. If I want to shift it left, it's going to be x plus h, and it'll shift that many. Okay? And then the very last, if I want to stretch it vertically, stretch or compress. That means that the A value out in front so if it's positive, it's going to grow by a factor of A. If it's a fraction, it's going to be squished. It's going to get fatter. All right? So let's have you all work on this to show what you can do over the weekend. Let's see, page 164, 74, 75, 83, 84, 97 through 100, 107, 111, 115, 119 through 126. That's all I got for you.